Hi, in this session, we will see how to complete a Capstone project on text data. Imagine you are working on a social media company. The company is concerned with growing amount of fake news circulating on its platform. They have assigned you to investigate how fake news can be recognized and create a method to identifying it. Let's work through this problem together, first by exploring and cleaning the data and then working to classifying fake versus factual news stories. We will also create some plots of our output and discuss how we would communicate our findings to stakeholders. Let's see one by one what kind of scenario we can go here. Okay, first and foremost, I'm going to import data. For this, I will be using some library. So for example, pandas and matplotlib. Then I'm going to set plot options. For this, I'm going to use these keywords. For example, these are figure size, how to make a figure of this graph, how to set default color. So then I'm going to use a variable data equals to pd dot read underscore csv, and then inside this I'll be writing my file name. My file name will be fake underscore news underscore data dot csv. Make sure, do I have this file in my portal? So I'm going to navigate this portal here and let's see, do I have this file? No. So I'm going to upload this file, going to this text file, and can you see anywhere fake news data set? Yes, this is showing this fake news data, and I'm going to import this one. Let's see, we have imported this data set. Yes, we have imported this one. Now go back to our portal, hit run. Let's see ingredient of this data dot head. So I'm going to hit this one. Can you see this is showing title, text, data, date, factual or fake. So this is defined into two different categories. Let's see what kind of data is there, info, and what kind of columns are there. Here we have title, text and date format is there. Then I'll be using import basic library for processing. Then after this I will using part of speech tagging. Then I'll be using named entities for this defined data. Then I'll perform text pre-processing. Then I'll go with sentiment analysis, LDA, TF-ID and LSA, and predict fake or factual news on the given test data set. Okay, so let's go back ahead. I have just checked the information of my data set. Let's see what kind of data in the output we are having. Okay, so I'm going to define this graph where I'm just checking. This is showing the count. So what is the count here? Here I can see the count is given near about 100 of my data set and near about 98 of my given data set. So this is the statistical value of these two classes, factual news and fake news. So we have more factual news, but these two classes are defined in or more or like almost equal numbers. Let's import all these library. I'm just already written this one here. If anything not installed, you will have to use pip install and import that library. So luckily we do not have any undefined library here. If you will be using this pip install with our sentimental, you can use this values as well. Now I'm going to perform POS. What is the POS? It is the part of speech tagging. So for this I'll be using this spacey library. I'm going ncore verbs here. If you do not the meaning of this term, you just go back to my previous video so that you can have all these explanation and illustration part. Let's run this code, and then I'm going to split this entire data into fake news and factual news. So I'm having two columns. First one is my factual or second is my fake news. Okay, now I'm going to create a spacey column. For this spacey document, I'm going to create this one. Can you see this is showing NLP.pipe? Why pipe? What is pipe here? So pipe is a batch processing method in spacey that allows you to process multiple text efficiently using a generator. Instead of processing each text separate, using NLP text dot pipe process them in a stream, reducing memory usage and improving speed. Okay, so I'm going to run this cell so that we can process everything in a parallel way. So it is using data frame and we are converting everything into several form. So meanwhile this is going to process, I'm going to create a function to extract tags for each document in our data. So I'm going to create this function. The name of this function is extract token tags. So I'm going to create this one. Now I'm going to tag fake token data set first. So it is showing there. So I'm going to create everything here. So what will happen here? Here you can see this is the relevant piece of code. I'm going to create these columns: token, NER, and name entity relationship, and then parts of speech tagging. For this I'm going to enumerate these spacey documents and going to tag extract this one. First I'm going to create a data frame, then I'm going to create all the columns and parsing every columns and append in the given text. Okay, now let's see what kind of other processing I can do. I can also tag factual data set in the same code, and then I'll be concatenate these two terms. So I'm going to use this term and let's run. Can you see it just creating this particular final data frame? And now I'm going to see what is the ingredient of this fake tag. Can you see it is having NER tag and it is having parts of a speech tag as well. So we have two texts in a single speech, a single cell, and we are going to use this. So throughout the project I'll be using this term very frequently. Let's see what kind of token is there. I'm going to create a token for the POC tagging and the count, and in a ascending order. We have more punctuations than determinant and then punctuations. These comma, the, dot, of, these are in decreasing order. These are more parts of a speech in my given final processed data. Let's see in a similar way what is the highest part of a speech in fact data set. So I'm going to sort in a descending order. Here you can see the comma of in me more and same. So here in the fake news and here in the fact news. So we have these number of parts of a speech. Now find the frequency of position text. So I'm going to create this code so that we can count and sort values in a descending order, and here I'm going to create noun, verb and preposition, and everything is showing here. Now let's see what kind of fact news do we have. So I'm going to create this fact and going to group by using the parts of speech, sending, sort values, ascending, fails. Now we have all these values in ascending order. So noun, verb, everything are showing here. Now I can dive into differences into nouns as well. So I am going to check whether noun, how many nouns are present. Can you see these are common noun present: people, tea, present, woman, time, year, everything is present in this text. Let's see what kind of other nouns are there in the fact. So this was the fake news column, and this is showing the fact. So again inside the fact column we have government, year, state, administration, president. These are present noun in that column. Now let's see named identity. So I'm going to create a name identity here. So for this I'm going to create this tag for what is this one. So for this I'm going to first clean this one. So whatever name is there, it is not going to tag this one. Okay, if it is having this NER tagging, it is going to count this value and ascending in decreasing order. Okay, so I'm going to create everything in a descending order here. Let's run this cell so that we can see next top identity is in fact news. So I'm going to create a same piece of code. So hit enter and run this cell. You can see this is again NER tagging and going to append in the same column. Now in a similar way I can create other values. For example, I'm going to create majority of tagging. For example, these ensure plots, set to, organization, geopositional entities, nor, person, date, cardinal. I'm having all these. I require only these NER tagging only and skipping everything else. Let's create a graph for this. So most common identities in make fake news. What kind of graph we can create? Can you see this is showing most common fake? So Trump is there, the Clinton, Dolan, these are most common entities in fake news. Okay, let's see most common entities in factual using the graph. So I can create the same graph in a descending order, and this graph is showing the US, Reuters, Trump, House. These are most common entities in factual news. Okay, now once we have done this text processing, let's see what kind of other processing we can perform. So we can perform other processing. For example, this will be for example, I'm going to perform this text analysis. I'm going to clean this data set. So first I'm going, a lot of actual news has location tag at the beginning of the article. Let's use the regression to remove this one. So I'm going to regrade everything. So this is the hyphen symbol, this is the space, and everything is just going to create. Now I'm going to convert into lowercase, and then let's run this cell, and then I'm going to remove punctuation of this one. So for the same cell I'll have to use the regression part. So RE, so I'm going to use /w and /s, and then I'm going to use my NLTK for my stop words. So I'm going to use this stop words, going to check this against our most frequent n-grams. Okay, so I'm going to use this stop word term, and with this stop word I'm going to print this one. So these are all the stop words which I'm going to remove from my data set. So let's remove the clean data set which we have done earlier. So I'm going to remove everything from my data set. This would be final data set. So let's see what kind of punctuation we have. So here we are supposed to remove all the punctuation in this part. Then once we have removed all the punctuation, we are going to convert this text data into tokens, a small piece of code, so that we can move ahead. And also we can perform the lemmatization so that we can obtain basic dictionary format of this data set. So we are creating a new column named text clean, and this column is just converting into small piece of code. Let's see final ingredient of this data column. Can you see this is having fact and this is having fake and factual, everything is there. This is just clean data set. Here we have actual title, here we have text, here we have text clean. So this is the final output with certain pre-processing output. Okay, so we can leverage out of the box functionality of this NLP so that we can move ahead with machine learning algorithm. Let's find most common unigram after pre-processing. So here we can see the set Trump where we have only one unigram. So we have seen two unigrams also, so we can use this one unigram only, and going to extract the clean from this one, from this tuple, and so that we can plot this value. Can you see this is going to depict most common unigram after pre-processing here. Now I'm going to find bigram after pre-processing. This was consisting only one word at a time, and here I'm going to use two words at a time. So this is just pairing where we have two words at a time. Okay, now let's see how we can perform sentiment analysis of this one. For this I'm going to use Vader sentiment analysis to get neutral or positive or negative output sentiments. I'm going to create a bins for this. So for this I'm going to create first I'll have to use this data, where I'll be using this data text. I'm going to apply this Vade sentiment for my polarity score. If you do not know what is the polarity score, you just go back to the previous videos. You will find in LLP section polarity and Vade sentiment analysis. So here it is checking the polarity of my sentiment analysis. Then I'm going to check the bins of it, is going to create labels, and this label will be depicting negative, neutral and positive. Let's see what kind of graph we can obtain this one. Here you can see this is showing the colorful graph for my positive, negative and neutral output. So using this graph you can identify that what kind of data set do we have. So we have more positive and medium negative and very less neutral sentiment analysis inside the which graph inside the factual or factor. Okay, let's see, we have fake or factual. I'm going to convert this graph again so that we can see sentiment by news type as well. So here we can see all the fake news and factual news also in a similar way. Okay, now I'm going to perform LDA for the fake news data vectorization. This would be converting my data into vectorization form, and I'll find this this term for my certain topic. So for this I'll be using this coherence term, where I'm just using my topics ID dictionary, and this would be certain output. Let's create this graph so that we can go ahead with this term, and we'll be creating a graph out of this. And this is based upon my in between 2 to 11. So in between I need to choose certain optimal value for my topics inside LDA, and I will have to select in between minimum topics and maximum topic 2 to 11. So this graph will depict what kind of topics you need to select. Okay, so this would be the optimal value, and here you can see this graph will depict what kind of optimal value you can select there. In this code you can see I'm just using my GenSim library to use LDA model. Here I am going to use this textual data. This is the number of topics for each minimum number and maximum topics. Here I am going to use dictionary fake or ID word, which will be parsing everything here. Then I'm going to use this coherence model to append everything inside the given empty list. Initially this is empty and it's going to add everything here. Here you can see this is going to append everything in this list. So whatever value will be there, it is going to append in each iteration. Finally I'm going to create a graph for all the topics, like from topics 2 to 11. I'm going to create a graph, and this would be number of topics versus coherence score, which means on the basis of these topics what would be the optimal solution we need to select. That's the meaning of this entire code. Okay, here you can see it took around 2 to 3 minutes, and finally we have this graph which is showing number of topics. So inside this graph you can see number of topics are near about, here you can see 6. So this is the optimal solution where we are obtaining where values. So can you see this is the optimal value. So this is the peak. I'm not going to select this peak value, rather I'm going to select this value which is near about this data set. Okay, so here I'm going to select this value so that I can create LDA model for my each topic. Okay, so I'm going to select these fake topics 6 and then going to perform everything. So relevant to all these 6 topics. So here I'm having all these 6 topics, 1 2 3 4 5 6. So relevant to these 6 topics, I am having certain words, respective words, and their weights in respectively in the associative model. Okay, so you can go back anytime and you can check what kind of operations we can perform over this model. So once we have created the extracted model for LDA, we can go ahead and we will be creating TF-ID for this. So I'm going to create a graph, and for this I'm going to create a function for my TF-ID using the corpus. So once it is again created, so I'm going to create a graph TF-ID. For this I'm going to create a model for this. Can you see it's just created this value? Now let's see what is the TF-ID presentation of this graph. I'm going to create this term and going to create the coherence score for each the document as well. So this is again 2 to 11 and it will take some time so that you can see what kind of final output. Alright, you can see it took 3 to 4 minutes to create this graph, and here we can see the final respective TF-ID corpus, and here you can see the more value we have near about 5, which means this graph is rotating near about this one. So this is the optimal solution we can see. Okay, so here this is the final peak value. Okay, so this TF-ID is nothing but relevant value of each term. So I'm going to create this TF-ID for every word with respect to entire corpus. So what kind of model we can create for the fake news data? So I'm going to create this code for my fake news, and number of topics I need 5, because this would be the relevant topics. Let's predict fact or factual data set. Once we have everything here, so I'm going to create this one value. So let's see what's the ingredient of this data. Here we have everything in this textual data set. Okay, so inside this one I'm going to use the X value and Y parameter for different values. So I'm going to create 2 different text. First is the clean data set and second is the fact or factual, which is consisting class value. Then I'm going to create tokenization so that we can have the tokenization term. So I'm going to create this tokenization term and this bag of words will be there. Okay, so let's see what is the ingredient of this bag of words. So here I'm going to use this head and going to display. Can you see it has converted every word into the numerical values, which is necessary for machine learning algorithm. So this is giving complete understanding of conversion, that we are getting feature names, we are converting into array, we are fitting this transformation, and we are converting text data into numerical format. This is the meaning of this code. Let's split this code. Once we have converted into numerical value, not the text value, we are dividing into 30-70 ratio using this X train and Y train and train test split data. And I'm going to use this logistic regression. You can use other algorithm as well, as we have seen in previous video, support vector machine or any other machine algorithm, so that you can predict over the test data set. So I'm going to predict my X test and then I'm going to check the accuracy of this part. So I'm going to check the accuracy score. It is very good, 85%, which means my classification report will also be good. So I'm sure you are keen interested to get now with other data set. Get data from any other resources, blog, website, and try to find this entire scenario. So let me see what we have done here. We have just completed a capstone project on text data. We have just fake and factual news, and then we process everything and then perform the final machine learning algorithm over this text data. This is how you can convert and you can deploy any other prediction over this value we are going to deploy. Thank you so much. Keep learning, keep growing.